Welcome back to the Deep Dive. We take your sources, dig in, and pull out the key takeaways for you. Today we're getting fundamental, really foundational stuff. We've got this text you sent over breaking down fractions and decimals.
That's right. And our mission really is to quickly unpack the main ideas, the definitions, the rules, the different types, and even some neat shortcuts in there. Make it all clear and useful for you.
Okay, let's dive right in then. Fractions first. What's the core definition from this source?
At its simplest, it's a part of a whole, written like A over B,
Right. A on top, B on the bottom.
Exactly. A is a numerator, how many parts you have. B is the denominator, how many parts make up the whole thing.
And the source highlights some really key properties based on those numbers, doesn't it?
Yeah.
Like, what if A and B are the same?
Yeah, well, assuming B isn't 0, if A equals B, the fraction is just 1. Like 5B is 1 whole.
Okay. And if the top number, the numerator, is 0.
Then the fraction's value is 0. Simple as that. Fractally equals 0. As long as the bottom isn't 0, of course.
Ah, right. And that brings us to maybe the most critical rule the source mentions.
Yeah.
What if that denominator is 0?
That's the big one. Division by 0 is undefined, period. The source is clear. A factual order of values is just not a defined value in our number system. You just can't do it.
Crucial point. Okay, the source also dedicates a specific rule, Rule 4, to multiplying or dividing both the top and bottom by the same number. Why is that so important?
Well, that rule is kind of the engine for manipulating fractions. If you multiply or divide the numerator and the denominator by the same non-zero number, the fraction's actual value doesn't change.
So it looks different, but it's worth the same.
Exactly. That's how you simplify fractions, finding the lowest terms by dividing out the highest common factor. And it's also how you get common denominators when you need to add or subtract them. It's fundamental.
Gotcha. Now, the source lists different kinds of fractions, too. Simple, complex, decimal, vulgar, proper, improper, mixed. Which one should we focus on?
Well, practically speaking, the proper, improper, and mixed distinction is probably most useful day to day.
Okay.
Proper is when the numerator is smaller than the denominator, like frac 3, less than 1. Improper is when the numerator is bigger or equal, like frac 4, that's more than 1.
And mixed is like a whole number and a fraction bit.
Right, like $1 frac 4. And the source shows how you can switch between improper and mixed pretty easily. Decimal and vulgar just refer to whether the denominator is a power of 10 or not, really.
Okay, powers of 10. Good transition to decimals.
It is. Decimal fractions are essentially those fractions with denominators of 10, 100, 1000, and so on.
Represented using the decimal point.
Yep, the point is key. It separates the whole number part on the left from the fractional part on the right.
And the digits to the right have specific place values.
Correct. Tenths, hundredths, thousandths. Matching those denominators 10, 100, 1000.
The source mentioned a handy little rule about zeros and decimals.
Oh yeah, that's useful. Adding zeros onto the very end of a decimal, the far right, doesn't change its value. So 0.76 is exactly the same as 0.731 or $0.700.
And taking them off doesn't change it either if they're at the end.
Right. Good for cleaning things up sometimes.
How about going the other way? Decimal back to a regular fraction.
Pretty straightforward method in the source. You just take the digits after the decimal point, put them in the numerator. Then the denominator is a 1 followed by as many zeros as there were decimal places. So 0 and 233 becomes frac.
Makes sense. Okay, the source also covers the basic operations, adding, subtracting, multiplying, dividing for both. For decimals, adding and subtracting seems easy.
Yeah, the rule is simple. Just line up the decimal points vertically. Then you just add or subtract like normal whole numbers. Keep the point in the same spot in the answer.
But multiplying and dividing decimals by powers of 10, the source has a really neat shortcut for that.
Oh, definitely. This is great for quick calculations. When you multiply a decimal by 10, 100, 1,000, you just shift the decimal point to the right by the same number of places as there are zeros.
So $3.14 times $100 is $343.
Exactly. And for dividing by 10, 100, 1,000, you shift the point to the left. $56.77 becomes $5.06. It's a really visual, easy trick.
Very useful. Now, shifting gears slightly, there was that section on using formulae as shortcuts. It gave this example, a fraxane 3 plus BA2 AB plus B2. That looks algebraic. Why is it in a fractions decimals text?
because recognizing that specific algebraic pattern is a huge time saver, especially when A and B are messy decimals or fractions. That whole complicated expression simplifies right down to just a plus B day.
Just a plus B day.
Just a plus B deal. The source includes it, I think, to show how sometimes knowing a bit of algebra can make complex-looking arithmetic problems incredibly simple.
And it gave a numerical example, right? Something with 6.3 and 3.7.
Precisely. It showed cracks in $6.33 plus 6.73 times 3.7 plus 3.7 plus 3.72. Like, it's awful to calculate directly.
Yeah, I wouldn't want to do that by hand.
But if you see the $3 plus B33 pattern on top and the $10 AB plus B22 on the bottom with A $6 and $3.03 and B $3.07, the whole thing just collapses to A plus B bool.
Which is $6, $3 plus $3.07.
Which is just 10. See? Recognizing the pattern saved a ton of work. It's about seeing structure.
That's actually pretty powerful. Okay, lastly, the source briefly covered LCM and HCF for fractions and decimals. Any key takeaways there?
Yeah, it gives rules. For fractions, the LCM involves the LCM of the numerators over the HCF of the denominators. HCF is the reverse. HCF of numerators over LCM of denominators. A bit technical, maybe?
And for decimals?
For decimals, the trick is usually to make them have the same number of decimal places first, then find the LCM or HCF as if they were whole numbers, and finally put the decimal point back in the right place.
Okay, so that pretty much wraps up our deep dive into this source on fractions and decimals. We've gone from the very basics, what they are, parts, the zero denominator rule, that key rule for...
Through the different types, the operations, lining up decimal points.
Right, and those shortcuts, shifting the decimal for powers of 10, and even spotting algebraic patterns like that O plus B barn trick.
And understanding this stuff really is crucial. It's the bedrock for so much other math and just quantitative thinking in general.
Absolutely. So here's something to ponder. How might paying closer attention to these fundamental rules and shortcuts change how you see numbers? Could looking for that hidden O plus B bot structure or remembering the simple decimal shift reveal an underlying simplicity in the calculations you encounter every day? Something to think about.